Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother Joel. We're here to hopefully show you how to approach studying for the SAT and also the actual how to approach taking SAT questions. We're going through the Khan Academy digital practice. If you want to see where we get this from, go back to our video on June 29th and we'll show you where we're getting these questions from. But they are essentially from the SAT sanctioned Khan Academy practice. I'm just going to click that off and get the annotation working. In the meantime, please read the question, come back, and we will do it together. Okay. Which of the following is an equation of the line A graphed in the xy plane that passes through that point and is perpendicular to the line whose equation is x is equal to negative 4.5. Ooh, I have to process this with a picture. A line, wait, the x is equal to negative 4.5 is this line, isn't it? Right? X is equal to negative 4.5 is this line. A line perpendicular to a vertical line is a horizontal line, right? Horizontal line, the equation of a horizontal line is y is equal to a number. What is the number? 3.5. Good job. So, problem like this, I always say, is one of the easiest problems on the test, but it is also one of the hardest problems on the test. Because if you try to use the y equals mx plus b formulation, y is equal to mx plus b, and you try to do it like this, you're going to have a problem. Big problem because the slope is infinite. You have a big problem with that. So in this situation, this is a situation of lines, but special lines, vertical and horizontal lines, and you got to be ready to catch those. And when you have a vertical horizontal line, there's special cases, and they use different methods. Vertical line is x is a number, horizontal line is y is a number. I bet Seth's going to have a slightly different approach on this.
No, I think this is the approach that really works.
You mean quickly?
I think, though, a pitfall of this problem is that someone might try to apply the method that needs to be used when you have a slopey line.
Right. Yeah.
In which the slopey lines, I mean by that is a line whose slope is not zero and is not infinity.
Right. Yeah. M times m perpendicular.
Suitably general formulation should work on this example too.
Right.
But actually not, because the routine that we learn about perpendicular is that two slopes are perpendicular when one of them is the negative reciprocal of the other.
Exactly.
And here, one of them, the slope is zero. One slope is zero, and the other is infinity. And in a way, they are negative reciprocals of each other in the sense that we could think of the reciprocal of zero to be infinity. So, so the pitfall is to recognize that this problem should be solved directly rather than by a routine method that's used to solve problems where the slope is oblique.
Right. Exactly. That's right.
So I wonder if we're going to see a problem similar to this, except the given line has an oblique slope.
You know, why not? Maybe we should try another problem now and see.
Okay.
Yeah, I mean, the way I think of it is a decision tree. When you have these types of equations, think of it as a decision tree. The first decision you make when you have the problem is it one of these special lines? Is it a horizontal, or I always say, is there a horizontal or a vertical line in the house? If there is, then you have to use this method of x is a constant, y is a constant.
Yeah.
If
Well,
it's
I looked
not,
at it a different. I looked at it a different way. I said, okay, well, we'll see if we could apply the general method, and then I looked at the equation and recognized that the equation told me the geometry right away.
Yeah,
That the equation x plus 4.5 equals 0 is an equation. The line is the vertical line. And so I said, oh, okay. And I could avoid using the principle and just say, okay, then the answer is a horizontal line. And the horizontal line, the equations for horizontal lines are the two bottom ones. And then I pick the one that contains the point whose y coordinate is 3.5.
right. Yeah. So we have to, yeah, and I sort of like to think about, so we have different approaches. I really like the decision tree where you decide first, is it a vertical or horizontal line first? And if it is, then you branch into that method of doing it.
But,
if not,
if you're given, if you're given an equation with an x and a y and some constant, and the coefficients of x and y, neither of them are 0.
Right.
Immediately it's an oblique line.
Right. And what we would call the
and so
an
equation and every oblique line must have an equation like this. But this equation doesn't have a y term.
That's right.
So it's not an equation for an oblique line. And then frankly, when I see an equation like this, I have to think twice to think about whether it's a vertical line or a horizontal line. And I say, okay, it says that x is constant. So I think of the constant value of x, and that makes it a vertical line.
Yeah. So I'm glad you said that you think twice about it, because I thought I was the only one in the world, or maybe one of many. Maybe a lot of people think twice about it. I'm glad you, who has expertise in math, also thinks twice about it, because someone like me who gets my left and right confused, my positive, negative confused, I always slow down. And I noticed I had to draw a picture. I had to actually see it as a vertical line. In order to know what's perpendicular to a vertical line, I actually had to see the vertical line. Then I know, perpendicular to is a horizontal line. Horizontal line, y is a constant. What is the constant? It's staring you right in the face. So, let's see how they do it. Okay. No, I need to, I need to do that. Wait, no, I need to clear all of our messy drawings. Stop this. I think this is what we said. Congratulations. We agree. Nice work. Thank you very much for that. Only 3 steps. We rewrite it like I did. See that? Because x is a constant value, it's going to a vertical line. Okay, they're thinking the way we are. Any line in the xy plane perpendicular to a vertical line is a horizontal line. Oh my God, look at that. The same method I used. Wow, look at that. Horizontal lines have the equation. K is a number. Real number. Boy, they're being fancy there. And therefore, you just pick off the y of 3.5. Wow, same method. So, great. So there's not... So, again, this question you got to be careful about. I know Seth's going to hate when I say this. Ready, Seth? I know you're going to get nervous. I think questions like these happen about 15% of the time, and oblique lines occur about 85% of the time. And you're going to say, where did I pull that out from? And I'm going to say...
Where did you pull that out from?
I'm just making it out of my hat. What's the expression? I'm pulling it out of my hat?
Yeah.
Yeah, Seth doesn't like that. Okay. It doesn't like that.
Well, you could survey the questions that and do and make a do the statistics on it, classify each question,
Yeah, but then
and
you have to
actually
decide where to get the questions from. So, anyway,
yes,
moving on.
yeah.
Okay, let's move on to the next one. Ready? Maybe this will be an oblique line. Okay, next question. Okay. Uh,
Okay, that's an oblique line.
you shouldn't have given it away. Got to give people a chance to.
Well, you look at it.
Okay. So anyway, everyone, why don't you try it and then try it, and we'll pause the video and we'll come back. What is the equation of the line graphing an xy plane that passes through that point and is perpendicular? Wow, look at this. It's okay. Decision tree. Are we talking about vertical and horizontal lines in the house? No, we are not. So Seth's already doing it. Y is equal to. There are too many equal signs there. What is that? Why do you have 4 lines there?
Because the computer was slow.
Oh, okay, fine. So then we can just. How about if I just make it 2 lines? Okay, how about that?
All right, and then it has to have 0.63. So 3 has to equal 1/3 of 6 plus b 2. So b equals 1.
Right, but
Well,
you
so
don't even have to. You
of
don't
x.
even have to write b is equal to 1. You just
A
go
third
direct.
of x plus 1 is y. And then just check it.
Yep.
Let's check it. Plug in x equals 3. Uh-oh.
No, x equals 6.
No, x. Yeah, oh, good. Oh, excellent. And plug in x equals 6. 6, so with 6 divided by 3 is 2, plus 1 is 3, which equals the y, which is the
Yeah,
3.
it's a good
Good.
idea to check that. It's a
Yeah,
good
it's a
idea
good
to
idea.
check that. Yeah.
Yeah.
Yeah, so that's pretty good. Now you definitely have to know that a line perpendicular to another line has a negative reciprocal slope.
Yeah.
Means if this is
Yeah.
negative 3, then the slope has
Mm.
to be a third.
Mm.
Yeah, and this is pretty classic. Pretty straightforward. This is the 85. I would say
Yeah,
85.
why is it negative reciprocal?
Oh my God! You really want to? Why is it the negative reciprocal? Ooh, yeah, good question. I can't really say because it is, right? That's not a good enough answer.
Well,
No, that's not a good enough answer.
here's a here axes. I'm going to use a.
Is it
Okay.
frozen?
No, here's a straight line, right?
Very nice straight line, by the way.
And okay.
Ooh.
So we have.
Wow, that's a really straight.
Yeah, I use straight lines. Let's call this delta x.
Delta x means change in x, like difference between
delta
two
y.
x values. That's the fancy Greek delta thing.
And now so it's like a rectangle. I'm going to use a line drawing.
A rectangle. Okay. That looks like a triangle to me.
I made a rectangle.
Oh, now you. Okay, fine.
And now you kind of turn the rectangle 90 degrees. And we get like this.
Okay.
Right. And then the distances. Well, let's see. Then the line was perpendicular. Looks like that.
Oh.
And let's see. So we're interested in the slope. Well, let's see. The new delta y, the new delta x, is minus the old delta y.
Right.
And the new delta y is the same as the old delta x.
Hmm.
And so the slope is the okay, that this is new delta x,
Right.
and this is the new delta y, and we take new delta y is the new slope, delta x, equals now new delta y equals the old delta x. And the new delta x is the minus old delta y.
Wow, look at that.
And so the original slope is delta y over delta x. This gadget equals the negative of 1 over
Sure, the reciprocal of, sure.
delta y over delta x, which is, of course, negative delta x over delta y.
Very nice. So, yeah, that's very cool. Now, two comments, though. You have to sort of say them when you make a transformation of a 90-degree rotation. Nothing changes, right? The two rectangles have to
rigid
be
rotation of
rigid
90 degrees.
So that's one assumption. That's not assumption. That's something you need to apply. And also, doesn't that mean that every line every line that you have on this one, when you make a 90-degree rotation, every line then becomes 90 degrees, a 90-degree change? Yeah. Every line suffers a 90-degree change.
Took the whole, I rotated everything.
Right. So if you
what I did was rotate around this point 90 degrees, so that this long horizontal segment got transformed into a long vertical segment.
Right.
This short vertical segment on the right got transformed into that, and this upper long horizontal segment got transferred into this way.
Right.
Rotate the whole thing 90 degrees.
But then also, what about this one? I have a line with a lollipop. Line with a lollipop. Then that also that also goes 90 degrees. Line.
No.
Line. Wait, how does it look?
I drew it.
Line.
I drew it. You.
No, isn't it line with a lollipop?
Nope.
Would go this way?
No.
Oh, yeah, you're right. Wait. Line with a lollipop.
The lollipop is coming out of the bottom. The bottom gets rotated to the right-hand vertical. Therefore, the new lollipop kind of comes out of the right-hand vertical.
Right. So the bottom, the handle of the lollipop is this one.
Yeah.
This is the bottom of the lollipop.
Yeah. And it's,
Right.
Yeah.
Right. Good. So everything gets rotated 90 degrees, right? Yeah. Okay. Yeah. So therefore, the diagonals get rotated 90 degrees. Wow, that's really cool. I don't think I've ever seen it shown, as opposed to just everybody always says, well, vertical lines have a negative reciprocal slope, but they never.
Well, frankly, I just wanted to show off that you could figure it out, or how to figure it out. But when I solve problems, I just use the rule.
Right. Yeah. But it's helpful to It's helpful to sort of at least see it once how to prove it, because that'll help you remember the rule.
Yeah.
Yeah. About the rotating the 90 degrees and
Yeah.
The other thing that's so important here that we used, that I think a lot of people don't necessarily realize how powerful it is this whole thing about just throwing the value in the equation to find B. I think many people forget that in order for if you have some sort of function, right, and you have a point here, let's say 7, 3, and you have some sort of f of x, right, or some sort of function y is equal to 3x plus 3x squared plus 2x minus plus 7 or something. If you want to see if this point is on the line, when you graph it, you plug the point into the equation and see if the equation is happy. See if it satisfies the equation. That's how you know if a point is on the line. And we're using that concept here because we don't know the b. So in some sense, we fudge the b so that we force this equation to be happy when when x is equal to 6 and y.
Well, let's put it more
simply.
Let's put it more simply. Let's put it more simply.
Put it more simply. I like that.
We know the form of the equation.
Right.
That's why you harp on y equals mx plus b. Y equals mx plus b. That is the form of the equation.
Right.
But in that form of the equation, m and b are not numbers. They for a particular equation they are numbers. But what we want here is we know the form of the equation. In fact, we know what m is, but we don't know what the b value is.
That's right.
So the b value is the unknown.
That's right.
Right? And so the b value is determined by the information that they give you in the problem, and the information in the problem gives you an x and a y value that the equation must satisfy.
Right.
So therefore, you plug in x and y, the values that they gave for x and y, and b becomes b is a unknown variable, and then but you get an equation that you could solve for b. That's how you find b.
Right. Yeah. But I mean, it is potentially confusing when you're just learning algebra.
Well, it is. Yes, it is. It's something that I think people are taught of at some point.
Yeah, but you always hear x is the unknown, x is the unknown, x is the unknown. But in this case, x is not the unknown anymore. B is the unknown. It's sort of like you can freak people out.
Well, when you talk about the equation of a line, y equals what's that line? Y equals minus 3x plus 5. X and y are not unknowns.
Right.
This is an equation for a line, and it means that the points on the line are those that have coordinates such that if you put them into the equation becomes true.
Right. Yeah.
Right. But you can consider it to be knowns and unknowns, because if the problem is find the x value for a point on the line whose y value is given like 7.
Yeah.
Then x is an unknown.
Right.
Or you might be asked, all right, find the y value for a point on the line with a given x, like 3. In which case x is known, it's 3, and y is unknown, but it's easy. The equation tells you what y is immediately.
Right. You just have to calculate it. Yeah.
Yeah.
So it's so important in algebra to really keep straight what your knowns and unknowns are, or what you're solving for, what you're after. So important to keep all of this in mind when you're doing algebra.
Well, it's a whole general, and in SAT questions, it's important to keep in mind, what is the question?
Right. Yeah. Well, yeah. What is the question? Right. Yeah. Okay. So let us clear. Let's just see how we did it. I forgot already how we did it. We definitely didn't do any of that red stuff that Seth did, because that was proving something. By the way, Seth, I really liked the way you did that and described that. That was really, really good. Notice how confident Seth is when he's talking. He really knows his stuff. And you really know it, right? You really understand it. That's why you're able to explain it so well. So let's see what we did. Yeah, so we just We just immediately wrote the 1/3 because it was a negative reciprocal, and then we solved for b. So let's see how they do. I'm sure they did it in a very similar way. We are doing this answer correct, right? Okay, let's see. Okay, so let's see how we answer the question. Ooh, look at this. Ooh, they're graphing it. Okay, we know the perpendicular lines have opposite reciprocal slopes. Is that would you have said opposite or negative reciprocal?
I said negative.
Yeah, opposite is not as good as negative. Okay.
Of course not.
Yeah, okay. Now therefore the line must have a slope of third. Seth is exactly, look at 2 or 4. That's exactly what we wrote. Because we know our line passes 6, 3, we can evaluate the y-intercept b by substituting 6 and 3. Solve for b. B is 1. The equation line, therefore, is that. They show a picture, which is very nice. So it's really the same way we did it. I mean, classic. Yeah. And there's really not that many different ways to do this problem. This very straightforward, classical way of doing it for a routine line.
So okay, well, let me tell the audience how I remember that the slope of a perpendicular is the negative reciprocal of the slope of the given line. I think of it like this. This is how I think of it. This is just me. But what I do is I think of a line, generic line, like that, right?
Nice line, by the way.
What?
It's a nice straight line. I know you use the line.
Yeah, that's because I use the line drawing.
That's cool.
And now, so, what's the perpendicular? Like Jordan blue. Nice perpendicular. Yep. Okay, now, first of all, what I do is imagine, I'm going to use black. I imagine this vertical here, right? And I know that the red line is on one side of the vertical.
What do you mean the black?
And the blue line is on the other side. Therefore, the slopes have opposite signs. One is positive and the other is negative. Or if it's the other way around, say this is the blue line to the right, the angle to the right angle is on the other side of the vertical, and so its slope is opposite. So I know for one thing, from this picture, the slopes of slope of one line compared with the perpendicular. One is positive and the other is negative.
Okay.
Second, if the red line is just a little bit slopey, then the blue line is very slopey.
Okay.
And if the red line were very, very slopey, like if the red line, I'm going to make it a red line. If the red line, okay, if the red line were very, very slopey, like that, then the blue line would be quite flat, like that. Right. And so that reminds me that the absolute values of the slopes are reciprocal.
Okay, that's a great visual way of thinking about it.
Yeah,
that's great. Okay, so I think that's it for today, right?
Yeah, actually I drew that.
We've used up a half an hour of everyone's time.
Yeah,
people thought it was worth it. Hopefully, if you're not, maybe.
Yeah,
I suspect most people.
I should really draw. So, yeah. Yeah, I was right before.
Yeah.
Okay.
Okay, sounds good. Okay, everyone, have a great day. Thanks for listening. Please like us, dislike us, give us comments on our YouTube videos. Please, if you have any SAT math questions, email us at satmathquestionoftheday@gmail.com. And we hope to see you tomorrow when we plow through, and we'll do another section on the SAT. They even have this thing called a little. What is this? Practice. The solving. Oh no, no, no. Where are we? Uh, yeah. Okay. Well, anyway, we'll deal with it tomorrow. Okay. So everyone, have a great day, and we hope to see you tomorrow. Take care, everyone. Bye.